Hello, warm greetings from High Target. High Target webinar is back. Today, our webinar will compose of 3 parts: presentation, Q&A time, and quick poll. During presentation, please keep quiet and listen to our presenter. In the Q&A part, you are welcome to raise your hands and ask questions. Our presenter will answer your questions directly. Our presenter today is Niki Wong. She is an excellent product manager of High Target International Group Limited, who specializes in RTK-related solutions and marketing. Hello, Niki.
Hello, everyone. Could you hear me? So really glad to see you. This time, I will introduce the health survey and Quasi-dynamic Technology in Hathaway Road for you. And we all know different survey methods for various measurement environments. And depending on the GNSS RTK data collection applications in the field, the measurement environments differ. There may be harsh situations, such as shaded areas or even unreachable points. And the health survey and Quasi-dynamic technology could solve the environment problems and promote work efficiency. So this time, I will introduce these 2 modes for you. Okay, let's get started. And I will introduce the health survey for you firstly, and then is the Quasi-dynamic technology. The first part is about the health survey. The most common situation that users will encounter is the need to measure the corner points. As you can see in the right pictures, the corner point is not easy to reach, and the horizontal status of the GNSS RTK receiver is not guaranteed. With this in mind, the health survey method is needed more than ever. By optimizing the health survey correction algorithm, the procedure can boost the efficient field work and minimize downtime. This method is more practical and widely used in many engineering projects. And in the high survey road, you could see the health survey includes 2 parts. The first one, you need to do the calibration firstly, and then you could do the survey. For the calibration, there are 4 steps. The first one is the orientation sensor calibration. The second is the electronic bubble calibration. The third is the magnetic calibration. And after these 3 calibrations, you need to do 1 verification to make sure the health survey calibration is success. And after the calibration, then you can do the health survey procedure. It can be divided into 2 modes. The first one is the normal slope, and the second one is the corner slope. And as the normal slope is much simpler, at the second slope, the corner slope, this mode is more precise. So I will introduce the calibration steps for you firstly. And the order of 1 and 2 steps can be reserved. It's the orientation sensor and electronic bubble calibration. These steps can be reserved, but it must be performed before the step 3. So you need to do the orientation sensor calibration and the electric bubble calibration. Then is the magnetic calibration. And the calibration should be done in the no magnetic interference area or open field. The calibration should be done in external station mode. Please don't use the internal UHF link to avoid magnetic interference. And also, please don't change battery and power off during all the calibration steps to make sure the calibration can be done successfully. Okay, so I will introduce the calibration to you one by one. The first one is the orientation sensor calibration. You can find the options in the additional settings. In the first picture, here is about the additional settings, and please choose this calibration and to get in this interface, the second interface. And if you want to get started, just click the Start button to begin the calibration. The calibration needs to be done according to a demo, and there will be a warning and a demo picture. You can do the calibration according to these two. So, how do we make the test survey calibration, the orientation sensor calibration successful? There are two pictures, picture A and picture 2. Firstly, you need to do as the picture A. Rotate one circle at a constant speed, about 7 seconds per circle, and then you move to the picture 2, picture B. Please clockwise rotate about 45 degrees. Then you can repeat the step A. You need about 8 circles at least. So the procedure is you do the option as the picture A and the B, and then back to the picture A and B again. So repeat this procedure about 8 circles. And after the calibration is completed in each direction, there will be a ding-dong sound to indicate success. Otherwise, you need to do this calibration again. So this part is all about the orientation sensor calibration. And the second calibration is the electronic bubble calibration. You could also find this option in the additional settings as the picture A, and then you need to make sure the device is leveled up and enter the additional settings to find this option to get the calibration interface. Click Start to do the calibration, and there will be a warning here. You can do the calibration according to the warning and click OK, so it will promote success. And it's recommended to do the calibration and to calibrate the device every 30 days. And the next one is about the magnetic calibration. After you finish the 1 and 2 calibration, we then move to the third one, the magnetic calibration. It's also in the additional settings. And you get in the interface to click Start to start this calibration. There will be a warning too, and it needs to do the calibration in horizontal position. So you can see this picture. This picture is about how to do the magnetic calibration. Firstly, you need to keep the device level and then rotate clockwise 1 week, slowly and in constant speed. The rotation speed is recommended to be less than 20 degrees per second, and the azimuth of the rotation you could say in this picture will be real-time displays. Also, after this calibration, there will be the ding-dong sound to indicate success too, and otherwise you need to do this calibration again. So this is all about the calibration. It can be divided into three parts. The first one is the orientation sensor calibration, and second one is the electronic bubble calibration. The third one is the magnetic calibration. So after the calibration, it's suggested to do a verification. This verification is to make sure that the calibration is all finished. You need to place the device on the pole held about 30 degrees and unscrew the knob and rotate it slowly clockwise for 1 week. You can check the animals change in the highway road interface, and if the difference between the maximum and minimum value is within 5 degrees, the status is normal. And please pay attention to that the pole shouldn't be moved, and the rotation speed should be about 2 degrees per second. It will take about 3 minutes to rotate 1 week. So this part is all about the tilt calibration and verification, and it includes 4 parts. The first one, orientation sensor. The second one, electronic bubble. Third one, magnetic calibration. And then is the verification. So which situations that requires the tilt calibration and verification? Please pay attention. If you first receive this receiver and it's completely new, or you first use it for the test survey, you need to do the calibration. Or you change to a new survey area and the terrain and environment changes greatly, you need to do the calibration too. Besides, after replacing one new battery, you also need to do the tilt calibration to make sure it can be worked directly. After you finish all the procedure of the tilt survey calibration, then you can do the tilt survey. The tilt survey can be divided into 2 modes. The first one is the normal slope, and the second one is the corner slope. The normal mode is much simpler, but the corner slope is more precise. And the corner slope mode is more stable too. Before you do the tilt survey, please make sure that the device supports the tilt survey function, just like the V90 Plus or RTK 5. So the hardware is important too. And now I will introduce the 2 different modes for you. The first one is the normal slope. Before you do the tilt survey, you must open this option before starting, and you can find this option in the Serving Configure, the data catalog, just like the first picture, and please open it, and then choose the method that you want. So in the second picture, we choose normal slope. After opening this function, you can do the normal slope tilt survey as the detail survey in the detail survey interface. So just keep the receiver tilt and static, and then to do the correction. The best tilt angle is 10 to 20 degrees. It will give a good precision. And after you finish the tilt survey, there will be the save point interface. You could see the tilt angle and the tilt azimuth of the point, just like the fourth picture here. This is all about the normal slope mode. And also, you could try the corner slope mode. This mode is more stable and can give better accuracy. So you choose this mode and you just to do the procedure like the basic slope. To keep the receiver tilt and static, and click the collection option. The best angle is the same as the basic mode. And after you click this button, you could see there is a pro mode about the color slope procedure. You can do your color slope just like this procedure. Firstly, you tilt it in one direction, and then you tilt it in another direction with an azimuth span angle of 30 to 120 degrees, and keep it static. So it's really similar to the basic mode, but just like you do twice of the basic mode in different directions to make it more accuracy. And after you finish the collection, there will be a sound promos just like B, indicating that the collection is complete. And also you could see some angle and azimuth of the point in the save point interface. So this part is all about the tilt survey function of the high survey road in the high survey road. So do you have any questions about the tilt survey part? Do you have any questions?
Okay, yes, I've got a question. Can you hear me?
Yes, are you William?
Yes, it's William. Can you hear me?
Yes, I can hear you. So what is your questions?
Yeah, my question is, are you guys gonna send us a PDF format, step by step on how to do the tilt measurements and to do all these corrections?
Yes.
Can you hear me?
Sorry?
Are you in a position to send us a PDF that actually tell us exactly on how to do this thing, this tilt correction step by step in a PDF format?
Yes. So you means that you need one PDF manual of this part to send to the customer, right?
That is correct. That is correct.
Sorry.
Yes.
Okay. So I will send the manual of this part to you to all the distributors. Yes, of course.
All right. Thanks a lot. Okay.
Okay. So do you have any other questions?
No, I don't have any questions.
Okay. Thank you. So is there anybody have other questions about this part, about the tilt survey procedure? So if not, we will move to another part. Okay, the next part is about the Quasi-dynamic technology. And some people may be asked why we need the Quasi-dynamic technology. In the heavily shuttled environments, such as under trees, the RTK signals wouldn't be stable, thus the precision will be bad and there will be some slip points. And the Quasi-dynamic measurement technology is a self-developed technology of high target, which greatly improves the serving precision in the harsh environment. So the specific algorithms, the algorithm to improve the accuracy is particularly important. This technology works as receiving the same data stream as the main board in real time, and use the self-developed post-processing engine to do the ultra-short PPK calculation, then combine with the real-time RTK result to improve the precision and reduce the save point. And what you need to pay attention to is that the difference between the accuracy and precision. The Quasi-dynamic technology only improves the accuracy, or only improves the precision, but not the accuracy. So you can look at this picture. The right picture. The first one is in no accuracy and no precision. And our Quasi-dynamic technology changed the first one to the second one. So we just improve the precision, but the accuracy will be the same as the old one. This is the Quasi-dynamic technology 4, and it could provide users with more stable and reliable fixed solutions. Okay, so now I will tell you how to use it in the Heisenberg Road software. Firstly, you need to open it. You could find this in the device, additional settings, and the receiver settings catalog. There will be one Quasi-dynamic RTK. You need to open it before you starting. And also, please make sure the device supports the Quasi-dynamic survey as the V90 Plus and IRTK5. So the hardware must support this function. And before you do this Quasi-dynamic technology survey, you should to make sure after the RTK correction data from base receiver or course servers has been received for more than 30 seconds, the Quasi-dynamic RTK survey is ready to work. So if you make sure you open this option and could have the correction data, then you could go to the detailed survey interface and click to start. In the first picture, you can see if you open this Quasi-dynamic technology survey, there will be one button, and you could click this button to start this Quasi-dynamic survey. And sometimes, if you get the promote PPP engine is under preparation, please make sure the receiver is getting correction data. And if can be used correctly, there will take about 20 to 40 seconds to finish the correction. And please pay attention that during the initializing procedure, please keep the receiver as steady as possible, and the rotating shaking is not allowed in the second step. But if you are in the calculating step, you needn't to pay attention to the shaking. You just to wait for the calculating is finished, and then there will be an interface about the save point, and you could see the information of this point. So the Quasi-dynamic technology is really used for the sleep point to improve the precision, and it's quite useful and it's not difficult to use it. Just open this function to use it. And during this steps, you could say there is a progress bar will be displayed during the measurement, so you could know how many times may be left to finish. And after the ding dong sound is 20, the collection is done and the point is saved. Just like this interface, you could see the information about the point. And in this mode, the normal detail survey RTK point collection mode is still available. So you could say in the first picture, there will be a button for the Quasi-dynamic survey, but you also could do the normal detail survey. You just to choose different button to get started and choose different modes for your survey. So this part is all about the Quasi-dynamic technology, and it's really simple. So do you have any questions about this part, about the Quasi-dynamic survey? Is there any questions about this part? If you have any questions, you can raise your hand in this in your PC software. Yes. Hello, William. Hello.
Yes. Oh, I've got just one question. When performing that tilt survey, can you hear me?
Sorry. Please speak
Yes.
slowly
Can you hear me?
Okay. Yes, I can hear you.
Yes. I've got just one question when performing the tilt survey. I think there's a point whereby you said we should be on static mode. Does it mean that if you are measuring RTK, one needs to automatically switch to static mode?
You means that if you are using the RTK mode, how to switch to the Quasi-dynamic mode is right?
Yes.
In this mode, the normal RTK mode won't be influenced by the Quasi-dynamic mode. So you can open these two modes at the same time, and you just click different button to choose them, so it won't be influence each other. Sorry, could you hear me?
Sorry, I missed you. I'll be honest.
Sorry?
Sorry, there was a connection error, so I missed you. Can you repeat, please?
Oh, you means that you didn't get this part about the Quasi-dynamic technology?
That is correct, yeah.
So I will repeat this part for you. Is that right?
No, you don't have to repeat it. I was just, I need clarity on switching between RTK and the static mode while doing a tilt survey.
Okay.
That was my question. Yeah.
Okay. So please look at this PPT. You could find that the option is in the device additional settings. Could you say this PPT, this part?
Yes, yeah.
Yes.
That's correct.
Yes. So in the additional settings, you find the receiver settings, and then you find this Quasi-dynamic RTK. You just open this option. After you open it,
Okay.
yes, after you open it, in this part, in the detail survey interface, you could see there will be one more button for this Quasi-dynamic survey. This button, could you say it?
Yes, I can.
Yes, this button is for the Quasi-dynamic survey, and the second button that as the below one, this one is for the RTK survey. Yes, so you just choose different button to click. If you want to do the normal RTK, you click the second one. if you want to do the Quasi-dynamic survey, you just click the first one. So you could just choose the options and then to do the different mode.
Okay, thanks a lot. That answers my question.
Yes.
Thank you so
So
much.
there is no more switching. You just open it and choose that one you want.
Okay, no, thanks. That answers my question. Thank you very much.
Okay, welcome.
Okay.
So do you have any other questions? Anybody have any questions about the Quasi-dynamic technology part? So if you have, you can raise your hand up. I couldn't see anyone raise your hand, so there is no more questions, right? So if you have any questions, you also could send the text message to me, and I also can see it. Okay, so maybe there is no more questions, and I couldn't see your messages. So this is all about the health survey and the Quasi-dynamic survey. And if you have any other questions about these two parts, or any needs, or other questions, you could send email to me. Also, you could use the WhatsApp, Skype, and WeChat to contact me directly, and I will give you some suggestions. So this is all about this course. And after this, we will have a quick poll about this part. So please wait for a minute.
Thank you, Nikki. Here we have a quick poll for you. Please choose the best answer for the following question so that we can adjust the key point of presentation for you. Did the presenter make herself clear? A, yes, I can fully understand her. B, yes, but I still have some questions. C, no, I can't understand at all. D, no, I can't hear her well because of internet connection. Yes, thank you. Thank you for your answer. Yes, thank you. We will try our best to present better webinar. And there is a survey when you expect to go to a webinar. It is about our next webinar. The theme of next one is frequently asked questions about applications of HD Max and USB. We will appreciate it if you could write out your doubts or anything you want us to know on it. Our presentation is over today. Thank you very much for Thank you very much for joining us. If you want to review today's webinar, please watch or download the recording on HiTarget's website or YouTube. See you next time. Beautiful goodbye from HiTarget.